The following scenario is hypothetical and presented for educational and entertainment purposes. The moment never arrives. No overturned tube, no rising mercury column, no quiet shock that the invisible has weight. In this parallel world, the concept of atmospheric pressure does not emerge, not because nature withholds it, but because no one ever frames the right question. The air remains an unexamined constant, an assumed emptiness that presses on nothing and yields to everything. And in that absence, science grows in a different shape, lopsided, hesitant, strangely grounded. At first, the consequences are subtle. Early engineers designed pumps that fail inexplicably, unable to lift water beyond a certain height. They blame craftsmanship, divine interference, even flaws in the material of water itself. Without the concept of pressure gradients, there is no theoretical ceiling, only a practical frustration repeated across generations. Wells remain shallow. Cities cluster tightly around surface water. The architecture of civilization compresses inward, not by necessity of land, but by ignorance of the forces above. Thermodynamics as a discipline never coheres. Heat is understood as motion, perhaps, but the role of compressible gases remains opaque. Steam engines emerge late and inefficient, their designs constrained by trial and error rather than governed by equations of state. Without recognizing that steam expands against external pressure, early inventors misinterpret energy transfer. Engines are built heavier, bulkier, overcompensating for a force they cannot quantify. Industrialization happens, but it limps, uneven and localized, like a fire struggling to catch in damp air. Aviation in particular becomes a philosophical impossibility. The notion that air could exert force sufficient for lift never crystallizes. Wings are built, tested, and discarded as curiosities. Balloons fail spectacularly, not because buoyancy is impossible, but because its governing principle is misidentified. The density differences between gases are observed, but without the framework of pressure, they are treated as anomalies rather than predictable outcomes. Flight remains in the realm of myth, not engineering. Education reflects this absence. Students are taught that air is present, yes, but inert, an invisible stage upon which matter performs, not an active participant. Without pressure, there is no unified explanation for weather systems. Storms are chaotic, unmodeled, attributed to complex interactions no one can simplify. Forecasting never becomes reliable. Agriculture suffers. Entire economies hinge on guesswork ritualized into tradition rather than refined into science. And perhaps most insidiously, ambition contracts. When a generation grows up without seeing the sky as something that can be measured, manipulated, or even understood, they stop asking how to reach it. Innovation narrows to what can be touched, weighed, and directly observed. The invisible is dismissed as unknowable, and therefore unimportant. The scientific method itself bends, less about uncovering hidden principles, more about cataloging the obvious. Yet anomalies accumulate. Pumps still fail at the same height. Flames behave differently at altitude. Sealed containers resist opening with a stubbornness that defies explanation. A few minds, restless, dissatisfied, begin to suspect that the air is not empty after all, that it presses, that it matters, that it is doing something no one has named. And somewhere in a workshop far from any academy, an experiment is being assembled, not to prove a theory, but to resolve a frustration that refuses to disappear. The apparatus is crude by conventional standards. Glass imperfectly blown, seals unreliable, measurements inconsistent, but its intent is precise. A column of liquid is inverted into a basin, not as a demonstration of principle, but as an act of stubborn curiosity. The craftsman behind it does not seek to redefine the nature of air. He only wants to understand why his pump cannot exceed its limits. Yet in this world, where no intellectual lineage points toward pressure, even the correct setup lacks interpretive power. The liquid falls slightly, stabilizes, and leaves a void above it, a space that should not exist if air truly exerts no force. The first climax emerges not from recognition, but from conflict. The result spreads quietly, then disruptively. Others replicate the experiment, each adding slight variations. Different liquids, different heights, different environments. The phenomenon persists. A stable column, a persistent gap. The absence of explanation becomes louder than any discovery. Scholars fracture into camps. Some insist the void is filled with an unknown substance. Others argue the liquid is self-supporting through intrinsic cohesion. A minority, small and increasingly isolated, proposes something radical: that the air itself must be exerting a downward force, balancing the column from below. This idea meets resistance not because it lacks evidence, but because it violates the unspoken assumption that air is passive. Accepting it would require reinterpreting centuries of accumulated knowledge. It would imply that every failed pump, every unpredictable storm, every inefficiency in steam engines shares a common cause. The intellectual cost is enormous. Institutions built on the stability of existing models push back. The anomaly is tolerated, even studied, but never fully integrated. Meanwhile, practical consequences intensify. Engineers, now aware that something limits their systems, begin designing around the mystery rather than solving it. Pumps are segmented, staged, extended horizontally instead of vertically. Industrial systems grow more complex, compensating for an invisible constraint. Efficiency remains low, but reliability improves through redundancy. The economy adapts, but at a cost. More material, more labor, more energy for less output. Progress continues, but it spirals outward instead of advancing cleanly. In parallel, atmospheric phenomena remain elusive. Without a pressure-based framework, altitude is not understood as a gradient of force. Mountain expeditions report dizziness, disorientation, even death, but these are attributed to fatigue or toxic vapors rather than reduced pressure. Weather systems are mapped descriptively, patterns of clouds, winds, and temperatures, but never predicted with precision. The sky is observed, not modeled. It becomes a domain of art rather than science. And yet the experimental anomaly refuses to fade. The craftsman's setup evolves. Others refine it, improving the seals, standardizing the measurements. Patterns begin to emerge. The height of the liquid column changes with altitude, with temperature, even with approaching storms. The data is undeniable. Something external is influencing the system. Something pervasive, variable, and measurable. The second climax builds not from a single revelation, but from convergence. Independent fields, engineering, meteorology, physiology, begin to notice the same correlations. The pump's limitation, the liquid column's height, the human body's response to elevation, all align. A new generation of thinkers, less bound by inherited assumptions, starts to connect these dots. They do not yet name it atmospheric pressure, but they describe its effects with increasing precision. And then comes the critical moment. A synthesis. Not a sudden epiphany, but a reluctant acceptance that the air is not empty, that it behaves as a fluid, that it exerts force, that it varies in ways that can be quantified. The concept, once unthinkable, becomes unavoidable. But by the time this understanding solidifies, the world has already adapted to its absence. Entire systems, industrial, educational, economic, have been built around workaround solutions. Recognizing the true nature of air does not immediately simplify them. Instead, it reveals how inefficient they have always been, how much energy has been wasted compensating for a misunderstood reality. And as this realization spreads, a new question emerges, not just what air is, but how different everything could have been if it had been understood from the beginning. By the time the concept finally crystallizes, air as a compressible medium exerting measurable force, the world is already structurally misaligned with the truth it has uncovered. Scientific language shifts rapidly, equations begin to form, and experimental validation accelerates. But the inertia of centuries cannot be undone in a single intellectual correction. The second climax does not arrive as triumph, but as destabilization. Industries that once relied on layered redundancies now face an uncomfortable revelation. Their complexity was never necessary. Multi-stage pumping systems, sprawling and inefficient, are suddenly understood as elaborate workarounds for a single misunderstood variable. Engineers, now equipped with pressure differentials and fluid dynamics, begin redesigning from first principles. Systems shrink, energy consumption drops, output increases, but this optimization comes at a cost. Entire infrastructures become obsolete almost overnight. Economic shock ripples outward. Factories designed around old constraints cannot compete with newly optimized designs. Skilled labor tied to maintaining redundant systems loses relevance. Regions that built their identity on complexity, on managing the unknowable, now find themselves outpaced by those who adopt the new science fastest. Progress, once slow and distributed, becomes abrupt and uneven. The world does not smoothly upgrade. It fractures along lines of adaptation. In academia, the correction is even more profound. Entire disciplines must be rewritten. Thermodynamics, previously fragmented and empirical, undergoes rapid formalization. Equations of state emerge, linking pressure, temperature, and volume into coherent models. What was once taught as a collection of exceptions becomes a unified framework. But this intellectual consolidation exposes a deeper issue. Generations of scientists were trained to ignore the invisible. Their methodologies, shaped by that bias, struggle to accommodate the new paradigm. Students now learn a different lesson. Air is no longer passive. It is active, dynamic, quantifiable. Weather systems, once chaotic, become predictable through pressure gradients. Storms are no longer mysteries, but systems governed by differential equations. Aviation, long dismissed, re-enters consideration with a new foundation. Lift is no longer an abstract hope, but a calculable force arising from pressure differences across surfaces. The sky, once a boundary, becomes a domain of engineering. Yet ambition does not expand immediately. Cultural momentum lags behind scientific understanding. A generation raised in a smaller world does not instantly recalibrate its expectations. Even with the equations in hand, the idea of flight feels implausible, not because it is, but because it has never been part of lived reality. Innovation requires not just knowledge, but imagination, and imagination has been conditioned by centuries of limitation. Gradually, though, the shift begins. Experimental aircraft, initially crude, then increasingly refined, demonstrate controlled lift. Weather prediction improves, stabilizing agriculture and trade. Energy systems become more efficient, enabling denser urban development. The world starts to expand, not geographically, but conceptually. What was once constrained by ignorance begins to open. And in that expansion, a final realization settles in. The delay did not just slow progress, it reshaped it. Technologies emerged in different orders, priorities shifted, and entire fields developed along alternate trajectories. The modern world, even after correction, is not the one that could have been. It is a version optimized late, carrying the imprint of its misunderstanding. The absence of a single discovery did not halt science, it redirected it. It forced humanity to build around a blind spot, to normalize inefficiency, to accept limits that were never real. And when the truth finally surfaced, it did not simply illuminate the path forward. It cast a long shadow backward, revealing how much of history had been constructed in the dark. What lingers is not the correction itself, but the cognitive aftershock. The recognition that reality was always behaving consistently, even when humanity was not. The air had weight, gradients, and measurable force from the beginning. It was human perception that failed to resolve it into a usable model. In this parallel world, that delay becomes a case study in epistemological fragility. How entire civilizations can orbit around an unchallenged assumption, mistaking absence of explanation for absence of phenomenon. The scientific community, now fully equipped with pressure as a foundational variable, begins to re-examine everything it once considered settled. Historical data, long archived as anomalies or noise, is reinterpreted through this new lens. Patterns emerge with startling clarity. The erratic efficiency of early engines, the unpredictable yield of crops, the physiological limits of high-altitude travel, all align under a single framework. What once appeared as disconnected irregularities now compress into a coherent system governed by gradients and equilibrium states. But this retrospective clarity introduces a deeper tension. If such a fundamental property of nature could remain unrecognized for so long, what else might still be missing? The confidence that once anchored scientific progress becomes more cautious, more self-aware. Methodologies evolve, placing greater emphasis on identifying implicit assumptions. Experiments are no longer designed to confirm hypotheses, but to challenge the boundaries of what is considered observable. The invisible is no longer dismissed, it is actively pursued. Technologically, the world enters a phase of accelerated convergence. Fields that developed in isolation begin to integrate rapidly. Fluid dynamics informs architecture, leading to structures optimized for wind resistance and pressure distribution. Medicine incorporates pressure-based models to better understand respiration, circulation, and cellular exchange. Even communication systems evolve, leveraging atmospheric properties for signal propagation in ways previously unexplored. The late discovery does not just correct, it catalyzes, yet the imprint of delay persists in subtle ways. Urban design, shaped by centuries of constrained resource movement, remains dense and vertically conservative. Transportation networks, originally optimized for inefficiency, resist complete overhaul due to economic inertia. Cultural narratives still reflect a world where the sky was unreachable, where limits were accepted rather than challenged. The collective imagination, though expanding, carries the memory of confinement. A new generation grows up in this transitional reality, one where the equations of pressure are as fundamental as gravity, but where the world around them still bears the architecture of ignorance. For them, the past is not just history. It is a demonstration of how knowledge shapes possibility. They learn that understanding is not merely descriptive, it is transformative. To know a force is to design with it, to harness it, to extend beyond previous constraints. And perhaps the most profound shift is philosophical. The discovery reframes humanity's relationship with the unseen. Air, once considered empty, becomes a reminder that absence of perception does not imply absence of influence. The world is no longer divided into what is real and what is measurable. Instead, measurement becomes the evolving bridge between the two. In laboratories and classrooms, a quiet question begins to circulate, not as doubt, but as discipline. If something as pervasive as atmospheric pressure could remain hidden in plain sight, then certainty itself must always be provisional. The pursuit of knowledge becomes less about arriving at final truths and more about continuously refining the lens through which reality is interpreted. And somewhere, in a future not yet defined, another overlooked constant waits, present, consistent, shaping everything, until the moment someone finally asks the question that makes it visible.